Welcome to an introduction to Infrastructure as Code presentation. I am Mohammed Hoche and I'll be talking to you about how to provision your infrastructure using Terraform. Before I get started into my talk, I want to give a big shout out and a thank you to all our lovely sponsors today: ScriptRunner, Redspire, Global Drive and Data Quality, Agilysys, Hitachi Solution, Proximo 3. Thank you all for making this possible. So now let's get started. I wanted to ask you all, have you ever had to wait for months for your infrastructure to be provisioned? If you've experienced this frustration, then you are not alone today, because Team Junction have been facing this issue for some time and are looking into alternatives in solving this problem. So you're probably wondering, what is Team Junction? So Team Junction is a multiplayer gaming company that has gained a lot of popularity in the last few months, especially during the pandemic. The game allows online players to interact with each other and play virtual card games. These card games are Uno or Spades. And they currently run their application on premises, but have recently decided to move to the cloud, especially Azure as a chosen cloud provider, due to elasticity and scalability features and also cost benefit reasons. Team Junction currently provision their infrastructure using the classical way, which consists of: a person would file a ticket such as "I want a virtual machine." Somebody will then log into the management portal and go through a series of steps in order for that virtual machine to be provisioned. This way of provisioning the infrastructure caused a lot of problems to Team Junction, hence why they are moving to the cloud and are looking for an alternative way in provisioning their infrastructure in the cloud. Some of the problems that they were facing when it comes to provisioning their infrastructure were that they often found it was time consuming. Like, it could take up to weeks or even months for your infrastructure to be provisioned in the classical way. And in Team Junction case, whenever they saw a spike in their application, they weren't able to match that spike due to the way they provision their infrastructure. Another problem with the classical infrastructure provisioning was they often made mistakes in configuration due to the manual steps, and also they found it very hard to track and audit changes in the classical infrastructure provisioning. So today we're going to be looking into like the alternative way, and the alternative way is what we call nowadays infrastructure as code. And infrastructure as code is a technique to treat your infrastructure provisioning and configuration in the same way you handle application code. And the benefit of infrastructure as code is that you can automate the provision of your cloud resources, you can create templates for reusability, and you can store configuration file in source version control so that it's discoverable and audited. And this kind of leads us quite well to what Terraform is. So Terraform is an infrastructure as code tool that allows us to treat the provisioning of our infrastructure in the same way we treat software code. Terraform is written in HCL and it's a declarative language. And what we mean by declarative language is that you write your code in such a way that you describe what you want to do and not how you want to do it. An example that I like to give is, imagine you're ordering a taxi. When you get to that taxi, you tell the driver the destination you want to go to. It's now up to the driver to take you to that destination, and you left that how to the driver. And this is what declarative programming language is, and this is why I believe it's a very common within the DevOps and cloud developer community, because of this feature that Terraform have. Before we get into our demo, I wanted to show you how the Terraform architecture is set up. The architecture is made up of two components. The first component is what we call the core. The core uses two input sources in order to do its job. The first input source is what we call the configuration file. This is where the user would write and define what needs to be created. The second input source is what we call the state file. This is where Terraform keeps the latest state of how the current infrastructure is set up. Once the core receives these two inputs, the core will figure out a plan of what needs to be done. So there's a comparison of the state file and the configuration file. And if there's a difference between the desired state and the current state, then Terraform core will then go through a series of steps in order to come up with an execution plan. The second component of the architecture, or the second part of the architecture, is the providers. These are providers for specific technology. This could be cloud providers such as Azure or AWS or other infrastructure as a service platform. But also Terraform have providers for more high-level components like Kubernetes or other platform as service too. So now going back to our core. So once the core creates an execution plan based off the comparison of the current state and the desired state, it runs that execution plan against the provider to execute the plan. If you want to join me in my demo, you will need the following tools. You will need an IDE or a text editor. Most IDEs support Terraform. You'll also need an Azure account. Azure provides you with a 14-day free trial in which you can play around with their services. You'd also need Terraform installed so that you can run Terraform commands. Now enough of the boring stuff and let's get started. Team Junction have given us a challenge of creating a storage account in Azure using Terraform. For those people who don't know what a storage account is in Azure, a storage account is a container that groups a set of Azure services together. These services are queues, blobs, files, and tables. Team Junction have also specified certain features for their storage account. They want their account to be standard, and they want the account replication type to be locally redundancy storage. To get us started quickly with our demo, I've imported a startup folder. Within the startup folder, we have a configuration file called main. Inside this, we've defined our provider. In our case, our provider is Azure RM. We've also specified the version of our provider we want to use, and we've stated that we want to use the minimum version of 2.46. Also in version 2, we have to specify a feature block. This feature block is used if you want to control the behavior of certain resources, but in our case, we are not really interested in that, so we are going to keep it blank. Before creating anything in Azure, I want to talk about the syntax in line 7. The first thing that's mentioned in line 7 is resource, and a resource in Terraform is a component that tells Terraform to create and manage this infrastructure component we are about to define. Then we have to mention our provider in quotation marks. In our case, our provider is Azure RM. Then we have to specify the type of resource we want to create. In our case, we have to create a resource group first. For those people who are not aware of what a resource group is, a resource group is a logical container that holds resources in Azure. In other words, we cannot create Team Junction storage account without having a resource group. And then finally, we have to call this resource object a name. By the way, this is the name to Terraform and not to be confused with the name of the resource group. We are not calling the storage account Scottish Summits. This is a name used for referencing and can be used to create dependency between different resource objects. We can now go ahead and define our resource group in Azure. There are two vital information needed to create a storage account in Azure. We need to give the resource group a name and a location. So let's go ahead and do this. So we've now defined our resource group. We can now go ahead and create a storage account for Team Junction. Again, we'll be using the same syntax as the resource group. We first need to define our component, which is a resource. Then we need to mention our provider, which is Azure RM. Then we need to mention the type of resource we want to create in Azure. In our case, we are creating a storage account. Then we have to give this resource an object name. Once this is done, we can now define our storage account in Azure. To create a storage account in Azure, we need to provide the name of the storage account. We'll also need to provide a location, a resource group that it belongs to, the account to, and the account replication type. All of this information can be found on the Terraform website, but let's go ahead and populate this. Instead of manually typing the name of the resource group for every resource we can create a dependency between the resource group and a storage account. And the dependency makes sure that a resource group should always exist before the storage account is created. To do this, what we need to do is first mention our provider, so Azure RM, then underscore resource group, then we need to mention the resource object name that created that resource group, so in our case, Scottish Summit. We then need to access the name of the resource group. To get access to the resource group name, we can do a .name, and that's it. We've now created that dependency between the storage account and the resource group. We can also do this for location so that the resource group and the storage account have the same location. Since now we've defined our resource group and storage account, we can move on to the next step, which is running the Terraform commands. But before we run any Terraform commands, let's look into Azure to see how things are currently set up. So currently in Azure we have 0 storage accounts, 0 resource groups. So we expect this Terraform script that we've defined to create a resource group for us and a storage account for us. So let's get started. The first command that I like to run always is az account show. And what this command does, it shows us which subscription we are currently in. So we're currently in the right subscription. Then I like to run this command called Terraform init. And this is the first Terraform command. And what Terraform init does, it looks into our main.tf file, it checks which provider we've defined, in our case it's URM, and then it downloads or installs all the necessary plugins to interact with the Azure API. So let's run it. As you can see, it's installing the HashiCorp Azure RM plugin, and Terraform has been successfully initialized. Perfect. The second command I like to run is Terraform plan. And what Terraform plan does is that it does a dry run of our code. So we can see all the changes that will take place. It will show us if Terraform is going to delete, modify, or create any resources. So let's give this a run. So this is the output from the Terraform plan command. It's telling us that it's going to create 2 resources, it's going to change 0 resources, and it's going to destroy 0 resources. Let's go into it in more detail. So the first thing it tells us is the action. So it's going to create with a plus green sign. It's going to create a resource group for us called Scottish Summit 21, and it's going to create a storage account named Team Junction Storage 2021. You can see a lot of the details are currently unknown. They will only be known once we deploy them in Azure. So if we're happy with that, we can now run this Terraform apply command, and this command will go through a similar process to the Terraform plan command. Now got the output from the Terraform apply command. Again, it'll be showing us what it will be creating in Azure, in our case a storage account and a resource group. If we're happy with that, then we can hit yes. Then it's going to run our code, and hopefully it will be creating our resources in Azure. So this is the output from the Terraform apply command. It stated that it has created 2 resources, which are our storage account and our resource group. So let's go off to Azure to see what's over there. So here's our resource group, looks good. And here's our Team Junction storage account, perfecto. And this is how simple Terraform is. Let's do a little challenge. Let's change the account replication type from GRS to LRS. Also, one thing I didn't talk about is the Terraform state file. So once we run Terraform apply, our Terraform state file has been populated with our current state of our Azure infrastructure. So we have a storage account and we have a resource group. Okay, now let's change this account replication type from LRS to GRS. Will Terraform be clever enough to realize the difference between our desired state and our current state? Let's give this a try. Let's first of all go for a Terraform apply. Plan. Now receive the output from the Terraform plan command. It's realized there's a difference between the desired state and the current state. Let's see. It realized that we've changed from GRS to LRS. And let's now try and let's apply those changes. Terraform apply. Again, it will go through the same process as Terraform plan, but again, it will give us that approval stage at the end. So we've received a response from our Terraform apply command. It's given us the same output as our Terraform plan, but it's also given us the option whether to perform this action. Since we are aware of the change, we can hit a yes on this. So we're going to hit yes. We have now received a response from Terraform stating that it has modified our storage account. And let's check Azure to see if it has made any changes. So currently we're set as geo redundant storage, and we're changing it to LRS. So let's refresh the page. Perfecto. We've now changed our replication type. Now to summarize what we've done today. We've created a resource group and a storage account for Team Junction. We've also looked into how to link a storage account and a resource group together. We've also spoken about the Terraform command and the useful Terraform commands. So now going back to Team Junction, we are going to be talking about what benefits Terraform gives to Team Junction when it comes to provisioning their infrastructure. The first benefit in using Terraform is that it's simple and fast. As you can see from our demo, it took us less than 3 minutes for a storage account to be created. Compare this to the classical way, where it could take you 3 or even months for a resource to be created. Also, Team Junction would also be able to verify changes using the Terraform plan command. This would only give them more confidence when it comes to deploying their resources or services in the cloud. And lastly, there are less manual steps required in Terraform compared to the classical way, therefore reducing human errors in the configuration file. We are now approaching the final 2 slides of my talk. If you are feeling inspired and you want to learn more, I've attached some links that I would 100% recommend you to look into. These links will provide you more information about Terraform, such as how to get started and the ins and outs of the CLI, so defo check these out. Unfortunately, this is the end of my talk. I hope you've all liked it and learned something from my talk today. If you have any questions for me, please feel free to pop me a message on LinkedIn. Also, if you are super inspired by my talk today, I've set up a challenge in my GitHub account, so give that a try. Finally, you can find my talk on YouTube after 14 days, and I hope you all have a lovely time in attending the Scottish Summit.